Lecture 19, actually the continuation of lecture 18. Lecture 18 already we discussed the power series expansion method or different inverse transform method, and this is a continuation of the previous lecture, lecture 18. Here again we will discuss another question related to power series expansion, how we can use the power series expansion to solve the problem. Here the question is given, find the inverse Z transform x of z using the power series method, or it's also known as the long division method, and the signal is given as a rational function, numerator and denominator, and we need to find out two signals, one if the signal is causal and another one if the signal is non-causal, or you can call it as an anti-causal also. First we will take the case when the signal is a causal. Okay, and when the signal is causal, means in generally we can say that in Z transform the modulus of Z is greater than value R. Okay, or we can say in time domain the signal contain only positive, not positive, n values are positive, means from n is equal to 0 to infinity. Okay, it can be in between this, there is no negative values for n. Signal is positive, only positive values of n. So start from this particular point. Okay, signal starting from this point, that's why x of z is written like this. It is in the form x of 0 into z raised to 0 is equal to 1, then x of 1 into z raised to minus 1, etc. Means it contains negative powers of z. Okay, so in order to solve this particular question, we need to first divide the signal, so that's why it's known as a long division method. So we'll see how we can solve this particular problem. So we need to divide the signal, and when you dividing the signal, always remember that the signal contain different powers. When it is a causal signal, we need negative powers, so means we need to start with highest order of this particular equation. So we take this, here it is minus 1 minus 2, so here it is z0, so we'll take the constant term, so highest order of z. So here the constant term is higher because it becomes z raised to 0. So we will start with the constant term in this particular example. So I'll rewrite this particular equation. I need to divide 1 by 1 plus 2 z raised to minus 1 by using 1 minus 2 z raised to minus 1 plus z raised to minus 2. Okay, and now I will divide this particular equation. So in order to divide, here the first term is 1, here the first term is 1, so I need to divide these two terms. So 1 divided by 1, I can say it's 1. Okay, and now I need to multiply this 1 by using this quantity, so I can write it becomes 1 plus, sorry, it's 1 minus 2 z raised to minus 1 plus z raised to minus 2. Okay, we got one term. So actually we are obtaining multiplying this 1 with this term. Okay, and now we need to subtract. So when you subtract this, you will get it becomes 4 z raised to minus 1 minus z raised to minus 2. Okay, it becomes plus. We need to subtract the second term, and now again we need to perform the division. So here we need to consider the term 4 z raised to minus 1 and 1. So if you divide 4 z raised to minus 1 by 1, so that's a process. So you will get 4 z raised to minus 1. Now I need to multiply this 4 z raised to minus 1, 4 z raised to minus 1 with the term. Okay, so I can write like this, it becomes 4 z raised to minus 1 minus 8 z raised to minus 2 plus 4 z raised to minus 3. Okay, now we need to subtract. So if you subtract this, you will get 0 here. Here it becomes 7 z raised to minus 2 minus 4 z raised to minus 3. Okay, now again I need to divide this 7 z raised to minus 2 by using this 1. So if you divide these two terms, I'll get 7 z raised to minus 2 by 1. So I'll get plus 7 z raised to minus 2. Now I need to multiply this 7 z raised to minus 2 by using this term. Okay, if you multiply that, you will get 7 z raised to minus 2 minus 14 z raised to minus 3 plus 7 z raised to minus 4. Okay, now again I need to subtract, so I will get 10 z raised to minus 3 minus 7 z raised to minus 4 is a remainder. Again, if I divide this particular term, 10 z raised to minus 3 by using this first term, okay, again I can write plus 10 z raised to minus 3. Again I can continue the method, so again there will be terms. Okay, it's an infinite series. Now we got an x of z, there is fraction, but I can write this x of z like this. Okay, it becomes 1 plus 4 z raised to minus 1 plus 7 z raised to minus 2 plus 10 z raised to minus 3 plus etc. So if you compare the equation, standard equation, here you can see the z raised to minus 3, here also z raised to minus 3, the corresponding term is x3. So if you compare like this, you got x3 is equal to 10. Okay, and if you compare another term, z raised to minus 2, here also z raised to minus 2. So that term corresponding to the coefficient x2, which is equal to 7. Similarly, if you write, you can write x of n is equal to, starting from 1, 4, 7, 10, etc. Okay, it's an infinite sequence. It will not get a fixed finite sequence. Okay, this is sequence x of n. Okay, and this is a starting point because it's a causal signal. And next we will discuss the second part, how we can solve the remaining portion if x of n is non-causal. If x of n is non-causal means the signal exists in the negative side. Okay, so normally start from minus infinity. Okay, from minus infinity to 0 you can expect 0 or minus 1. So the signal can expect from in this direction. Okay, that's why it's written in only the negative terms. So again we need to use the long division method, but when you use the long division method, a slight modification you need to perform. In the previous case we divide by using highest order. Now we need to use the lowest order, means we need to divide with z raised to minus 2. Okay, so I need to rearrange this equation to solve. So if you write like this, and slightly I need to rearrange this equation. So starting from 2 z raised to minus 1 plus 1, like we'll write. Initially it is 1 plus 2 z raised to minus 1. Similarly, the lower term will write first the lowest, z raised to minus 2 minus 2 z raised to minus 1 plus 1. Now we can divide. So if we divide, first we will take 2 z raised to minus 1 and z raised to minus 2. That's why it's known as lowest order first. So if you divide this 2 z raised to minus 1 divided by z raised to z raised to minus 2, so we will get 2z. Okay, the first term is 2z. Now we need to multiply with this, so it becomes we need to multiply with this term, so you can write 2 it becomes 2z raised to minus 1 minus 4 plus 2z. Okay, if you subtract this, you will get 5 minus 2z. Okay, next we need to divide this 5 with this particular term, so I can write 5 divided by z raised to minus 2, so it becomes 5 z square. So the next term will be 5 z square. Okay, if it is 5 z square, again I need to multiply with the term, so I can write it becomes 5 minus 10z plus 5z square. So if you subtract these two terms, you will get 8z minus 5z square. And now again I need to divide 8z divided by this, so 8z divided by z raised to minus 2, so you will get plus 8z cube. Okay, again I will multiply with 8z cube, so you will get 8z minus 16z square plus 8z cube. Again I will subtract, I will get 11z square minus 8z cube. So again I will divide this particular term with the first term, so again I can write plus 11 z raised to 4. Okay, in the similar way I can continue, so it like this. So x of z I can write 2z plus 5z square plus 8z cube plus 11z raised to 4. And if you compare with the standard term, okay, I can say like this: if there is a term z, it corresponds to is x of minus 1. Okay, so this is x of minus 1. X of minus 1 is 2, x of minus 2 is equal to 5. Okay, because z square corresponds to x of minus 2. And similarly, if you write, you can write this x of n. Okay, for minus 1 or it's 2. Okay, and minus 2 it's 5, then 8, then 11, etc. Okay, and for x of 0 there is no term, so I can write 0. So this is the anti-causal signal, because the signal exists only for the negative value, and the terms corresponds to this is for 0 term, this is minus 1, and this is minus 2, this is minus 3, and this is minus 4, etc. Okay, this is an anti-causal signal. Now we will discuss another question. Again here we need to find out is a transform using power series method. Here the signal power is given in terms of z plus 1 by z square minus 3z plus 2. Again we need to consider two cases: x of n is causal and x of n is non-causal or anti-causal. So we'll start with first question. Again we need to perform the long division here. Okay, first we need to perform the causal. So for the causal signal we need to choose the highest order. So here z square is a highest square, so I can write the term in this way: z plus 1. here you can write z square minus 3z plus 2. Again I can divide here, the first term I can divide, so it becomes z by z square, so it becomes z raised to minus 1. So the first term will be z raised to minus 1. Now I need to multiply with the factor, so it becomes z minus 3 plus 2 z raised to minus 1 divided by 4, sorry, divide not, we subtract these two equations, 4 minus 2 z raised to minus 1. Now I need to divide the first term, 4 by, I need to 4 divided by z square, so it becomes 4 z raised to minus 2. So here I will write 4 z raised to minus 2. Now I need to multiply with 4 z raised to minus 2. So the equation becomes 4 minus 12 z raised to minus 1 plus 8 z raised to minus 2. Now we need to subtract these two. So similarly, if you continue, next term will be, here you will get plus 10 z raised to minus 1 and minus 8 z raised to minus 2. Now if you divide this term, again I can write plus 10 z raised to minus 3. Okay, similarly you can continue. So x of n I can write, there is no constant term, so starting from 0 I can write 1, 4, 10, etc. Okay, so this is a causal signal. So there is no constant term, so starting from here, so this term is 0, so that's why I am writing 0, 1, 4, 10, etc. Okay, we'll do the next case. Here again we need to perform the signal for anti-causal signal. Here it is non-causal signal, we need to find out. For non-causal signal, the powers will be positive. Okay, there will be positive terms. So then we need to use the lowest order first. So here the lowest order is 2 z raised to 0. So I need to write the equation like this: 1 plus z. Okay, then here I need to rearrange like this: 2 minus 3z plus z square. Okay, I need to start with the lowest order. So first, if I divide 1 divided by 2, I can write 0.5 here. Okay, so 0.5 into this term, so it becomes 1 minus 1.5 z plus 0.5 z square. Now I need to subtract this, so it becomes 2.5 z minus 0.5 z square. Now I need to divide the first term, so you will get plus 1.25 z, and if you multiply with the term, okay, if you multiply you will get 2.5 z minus 3.75 z square plus 1.25 z cube. Now I need to subtract, and when you subtract this, you will get, after division, you will get plus 1.625. okay, and z square. Likewise it will continue. Okay, so I can write this x of n like this. So here the terms z square, etc. So if it is z, it's corresponding to x of minus 1. There is a constant term, okay, that's corresponding to z0. So I can write from 0 onwards, so it becomes 0.5, it corresponds to 0. Next it's 1.25 and 1.62, sorry, 625, okay, etc, etc. Okay, so this is the anti-causal signal. And now I'll give you some practice question. In the similar way we need to perform. One question is given, 1 by 1 minus a is raised to minus 1. It's very simple, but we need to use the power series method. That's very important. Okay. Similarly, again causal and anti-causal. Here also causal and anti-causal. Again, is in a rational form. Okay. The solution of this particular lecture, this questions we will discuss in the next lecture.